Hello everyone, welcome to the problem solving session from Capacitor chapter. This is the problem 48 from chapter 25 from Halide Walker. In this problem it said that a parallel plate capacitor with plate area 5.56 centimeter square and the separation D is 5.56 millimeter. And this capacitor we fill it with two different dielectric material or dielectric constant. The left cap of the capacitor we fill it with the dielectric material kappa 1, which is 7, and the right cap is fill it with the dielectric constant kappa 2. Then we have to find out the total capacitance of this capacitor. Fine, since this capacitor is filled with two different dielectric material, then it will act like a two different capacitor. Say we can say this one will a capacitance of that capacitor will be the C1, and this one the right side will act like a capacitance the C2. Then if we draw, say we're going to draw this capacitor. So this is actually that C1, and say this is actually that C2. This is C1 and say this is C2. Then the total capacitance of this capacitor would be C would be basically C1 plus C2, since they are in parallel with respect to that node. This is the node, this is the connection, so that means this is my connection over here. Fine. Now what is C1? Since we can find out the capacitance for parallel plate capacitor is, which is epsilon naught. A is the plate area divided by separation between the plate. With the dielectric constant, there will be a dielectric constant which is kappa. So that's when we can say that we can express the C1 would be the kappa 1. Now the area of this C1 or the capacitor 1 is separated by the separation is the D, but the area would be a half of that total area of the capacitor. With the same way we can write the C2 would be kappa 2 epsilon naught A by 2 divided by D, since the separation between the two plates basically the D. Now this information is given. The area of that total parallel plate capacitor is 5.56 centimeters square. I'll convert that to actually in SI system. That should be 5.56 into 10 to the power minus 4 meter square. Then the separation between the plate D is given, which is 5.56 millimeter. If I convert that to in SI system, it would be 5.56 into 10 to the power minus 3 meter. And the dielectric constant kappa 1 is 7 and the kappa 2 is 12. Now we have to find out the total capacitance of that capacitor. Now I'm going to plug in this value into the different two capacitors. Say that the C1, what is, I'll write it would be 7 is that kappa 1, epsilon naught is constant, which is 8.85 into 10 to the power minus 12, and that area is 5.56 into 10 to the power minus 4 divided by separation, which is 5.56 into 10 to the power minus 3 into 2. If you solve this one, then you will find out that capacitance of the capacitor 1 would be 3.097 into 10 to the power minus 12 farad. This is that value capacitance of the capacitor 1. and the C2 we can find out. Now C2 would be 12 is the dielectric constant, 8.85 into 10 to the power minus 12 is that constant, epsilon naught, and that area 5.56 into 10 to the power minus 4 divided by 5.56 into 10 to the power minus 3 into 2. If you solve, you will find out that capacitance of the capacitor 2 would be 5.31 into 10 to the power minus 12 farad. Now the total capacitance would be sum of these two capacitors, right? Now, so we can write total capacitance C would be C1 plus C2, which is C1 is 3.097 into 10 to the power minus 12 plus 5.31 into 10 to the power minus 12 farad. If you add, you will find out the total capacitance will be 8.407 into 10 to the power minus 12 farad. So that would be the total capacitance of this parallel plate capacitor with the two dielectric constant. So this is the answer of this question. Okay, thank you very much.